Today, July 12th, the Zhuque-2 Remote 2 independently developed by the private aerospace company Blue Arrow Aerospace, the rocket became the world's first liquid oxygen methane carrier rocket successfully launched into orbit. It has a two-stage configuration. The total length of the rocket is 49.5 meters, the diameter is 3.35 meters, the takeoff thrust is 268 tons, and the takeoff mass is 219 tons. The first stage of the Zhuque-2 rocket is composed of 4 80-ton liquid oxygen methane engines connected in parallel. Each single engine can swing in one direction, which can provide the rocket with attitude control in all directions. The second stage is composed of an 80-ton liquid oxygen methane engine and a 10-ton floating liquid oxygen methane engine. The launch did not carry a detachable payload, but only a non-separable dummy payload. This is not the first launch of Zhuque-2. On December 14, 2022, the Zhuque-2 Yaoi rocket carried out a launch in Zhuque-2. The main engines of the first stage and second stage rockets are normal, but the second stage swimming engine is not working properly. The satellite failed to enter the predetermined orbit, and the launch failed. Liquid oxygen methane launch vehicle technology has attracted a lot of attention because of the STAR rocket of the U.S. Space Exploration Technologies Corporation. At present, the world's major aerospace powers are scrambling to develop liquid oxygen methane engines. According to Zhang Xiaoguang, Deputy Director of the General Research Office of the Large Thrust Engine of the 11th Institute of Aerospace Science and Technology, China has been developing a methane engine since 2000. The 200-ton liquid oxygen methane engine will be used on the first and second cores of China's heavy-duty rockets, and its comprehensive performance indicators are comparable to those of the Raptor. So why is the liquid oxygen methane launch vehicle technology widely favored by the aerospace industry? First of all, liquid oxygen and methane rockets have excellent cost performance in commercial application scenarios. Liquid oxygen and methane are propellants with a high degree of civil and industrialization. They are very easy to obtain and relatively cheap. They are 1/100 the price of liquid hydrogen and less than half the price of kerosene. Once the liquid oxygen methane engine technology is mature and applied, it can be purchased in large quantities, and the cost is more controllable, which is very friendly to commercial aerospace companies. The oxygen required for the combustion of the same amount of methane is less than that of kerosene, so that the liquid oxygen carried is less, which can reduce the weight and volume of the rocket and reduce the cost. The temperature of liquid oxygen and methane is similar, the heat insulation between storage tanks is more convenient, and the storage is convenient and can reduce the cost. In addition, the carbon deposition problem of liquid oxygen methane after combustion is relatively easy to solve, which can reduce the cleaning work when the engine is reused, and reduce the maintenance cost of reusable rockets, and the reuse of rockets represents the future development direction of human spaceflight. The propulsion efficiency of liquid oxygen methane is good. The theoretical specific impulse is 355 seconds, lower than hydrogen oxygen but higher than liquid oxygen kerosene. The energy density is lower than liquid hydrogen but higher than kerosene. The engine nozzle diameter is small, combined with the pump back swing technology can greatly reduce the small size and weight of the engine, can put more engines in the rocket body, greatly enhancing the thrust of the rocket. In summary, money saving, high efficiency, convenient maintenance, and large reserves are especially suitable for large-scale repeated launches, making liquid oxygen methane propellants the focus of today's commercial spaceflight. It is currently the most ideal power for reusable rockets. Blue Arrow Aerospace CEO Zhang Changwu said that after more than half a century of development, the world's aerospace industry has entered a new stage. In terms of the types of rocket missions, from the original high-orbit launch missions to the low-orbit gathering, the new communications satellite network and remote sensing satellite network and other constellations are in full swing. This puts forward a demand for the development of launch vehicles with better economy, stronger transport capacity, and higher launch frequency. Under the clear market demand, The industry has established a plan for the development of launch vehicles with lower cost and reusability in the future. The liquid oxygen methane launch vehicle is a consensus choice formed under such a background.